In this section, we're going to look at simple interest and build this up to something a little bit more in line with what we've been looking with exponential functions and compound interest in the next section. So we'll start off defining some things here, and we'll do some examples and some problems. So simple interest is defined as the interest that accumulates only in the initial money deposited in an account. And this is called the principal. So we're going to see that P is the principal, or we can call it the initial principal balance. So this is the starting money that we might have if we're investing principal. So simple interest is not really used, but this is just a way to understand the concept a little bit better. So we're going to have the amount, or A, is going to be the final amount that we get on our investment. And the amount is going to be dependent on the rate. So this is R is going to be the interest rate. And it also depends on how many years that we're investing. T is, let's call it time in years. Okay, so our equation is going to be A, which is our final amount, equals whatever the initial principal is, P, times 1 plus our rate, which is going to be in a decimal form, times time, T. Okay, so Linda invested $1,000 for her child's college education. So this is the initial principal right here. So this is P. And we have $1,000 is our starting amount. And she saved it for 18 years. So T is 18 years. And our rate is 5%. And if we divide that by 100, we get 0.05 as it expressed as a proportion or a decimal. How much will she have at the end of 18 years? So we want to know what is the final amount. So we have A equals P times 1 plus RT. .05 times 18, and I'm just going to put that in my calculator. I'm going to write 1,000 parentheses 1 plus 0.05 times 18 close parentheses, and we get 1,900. So it almost doubled. Okay. Example B. Tori put $200 into a bank account that earned 8% simple interest. How much interest does Tori earn each year, and how much does she have at the end of the 4 years? Okay. So the principal at the beginning of the year is 200. So we got 200, and so this is simple interest. So our amount does not increase at the end of each year because we're only looking at the principal for simple interest and not what the total would be at the end of each year or each period. So We are going to, so the interest earned this year is going to be 200 times 8%, right? So if we multiply this by 0.08, right? If I multiply 200 times 0.08, that would be $16. So this is dollars here. So we would get 16 bucks. And so the total interest that we have earned is 16. The following year, we would still take the 200 and we would multiply that by our rate of 8%. And that would be $16 still. So total interest, we now have $32, 16 from the first year and 16 for the second year. And I hope you see it's the same for these other years. We would take the original principal and we would multiply it by the interest rate. And so I would have 32 the second year. On the third year, I would just add 16 to that, so that's 48. And then in the fourth year, another 16. That gets me to $64. Okay, so $64 of interest. Well, that would mean at the end of 4 years, I have the original 200 plus 64 bucks, and we have 264 total. And if I were to use our equation that we just introduced, we'll see A is the amount, our principal is 200, 1 plus 0.08 times 4. And we put this in our calculator, 200 parentheses 1 plus 0.08 times 4, close parentheses, and I get, no surprise, $264. I encourage you to actually type that in and discover that for yourselves, and not just write whatever I come up with. Find it yourself. Okay. Example C. Amy has $5,000 to save, and she wants to buy a car for $10,000. Okay, so it sounds like she has an initial principal of $5,000, and she needs that to grow to $10,000 in some future time so that she can buy a car. And she wants to know how many years. So she doesn't know the time that she needs to invest, but she knows she's getting simple interest of 10%. 10% is really good. And then it says, oh, well, what will the simple interest rate need to be if she wants to save for 15? Okay, so we're asking two questions here. One is, what is the T for this scenario? And then we're asking, okay, well, if we think of it in terms of the rate, sometimes you can shop around for different interest rates. Basically, they're going to be pretty similar. But let's say, for the problem's sake, she wants to know if she has 15 years to save, what would the rate need to be? So in this case, we don't know the rate. Okay, so we've got A equals P times 1 plus RT. We've got 10,000 equals 5,000 plus times 1 plus 0.1 T. All right, kind of crammed my space here a little bit. Okay, so 10% written as a decimal is 0.1. So we're going to solve for T here. We're looking for T. So what we're going to do is, first of all, start peeling away things to get t by itself. How about we get rid of this 5,000 by dividing it to both sides? We could distribute that, but it's way more easier just to divide. 10,000 divided by 5,000 is 2. 1 plus 0.1 t. Now let's subtract 1 to both sides. So I've got 1 equals 0.1 t. And now I have to undo this multiply by 0.1, so I'm going to divide by 0.1. And 1 divided by 0.1 is 10. If you're not sure, try it on your calculator. 1 divided by 0.1. Basically, we know to move this decimal point over 1, we multiply top and bottom by 10, right? So we get 10 years for that. So she would need to invest for 10 years at that interest rate to get that amount based on the 5,000 principal. Let's take a look at this part right here. So we were asked, what does the rate need to be to achieve her goal in 15 years? So we got 10,000 equals 5,000 times 1 plus r, and our t in this case is 15. Okay, now solving for r this time. So let's divide by 5,000. I feel like my brush is too thick here. Let's bump it down just a little bit. So I get 2 equals 1 plus r times 15. So subtract 1 to both sides. So I got 1 equals, let me just rewrite this, 15r. And then we divide by 15. And r is 1 divided by 15. It's 0.066 repeating. Another way we can write that is 6 2/3%. Okay, so if she's going to invest for a longer period, she can have a lower interest rate. Whereas this was 15 years at 10%. This was 10. Sorry, this was what do we get? 10 years at 10%. If we go 15 years, the rate could be a little bit lower to still achieve the 10,000 amount. Okay, so let's look at some practice here, guided practice. How much will a person have at the end of 5 years if they invest 400 at 6% simple interest? So we're looking for an amount. If they invest, P is 400 at a 6% rate for 5 years. So 400 times 1 plus 0.06 times 5. And we just put that in a calculator. So that's going to be 400. Let me look at the next page. 400. I got my work over here already, but I am going to double check it. 6 times 5 and 520. That's what I got before. So this is our amount. At $400 will increase to 520, so we're getting 120 in interest basically. How long will it take 3,000 to grow to 4,000 at 4%? Okay, so 4,000 is our A, and 3,000 is our P, and this is our rate right here, and we're looking for time. $4,000, 3,000 is our principal, our rate, and T is what we're looking for. So divide 3,000 to both sides. So yeah, that's 4/3, right? 4 divided by 3 is 1.3 repeating. So we got 1.33 repeating equals 1 plus 0.04t. So we're going to subtract 1 to that. In fact, I'm just going to say 1.33 repeating minus 1 equals 0.04t, and then we're just going to divide this whole thing by 0.04. So I still have my 1.3 repeating number in my calculator, and I'm just going to subtract 1 from that, and it's going to be 0.3 repeating, right? And then I'm going to divide that by 0.04. And it's going to give me 8.3 repeating. So t is, 8.33 repeating. So that's going to be, another way we can say that is 8 2/3 years. Right? So 8 years and 8 months, right? 8 months is 2/3 of a year if we wanted. What starting balance grows to 5,000 in 5 years with 10% simple interest? So balance grows to, so this is our 5,000. So that's our amount. And the starting balance in this case, that's our principal, that's P RT. So it grows to 5,000, that goes here. P is our unknown in this case, and we've got 0.10, that's our interest, times 5. 0.1 times 5 is 5. 0.5, sorry. 0.1 times 5 is 0.5 plus 1 is 1.5. So basically we got 1.5 times our principal, and we're going to divide that 1.5 to both sides. So we got 5,000 divided by 1.5. It's 3, I think it's 3 repeating, right? 5,000 divided by 1.5. Yeah. $3,333.33. Around to the nearest penny there. All right. Very good. That's our intro on simple interest, and I might do a video here for the practice, but I think you can probably figure out a lot of the practice on your own for this one. It gets a little more challenging when we start talking about compound interest, and we'll look at that tomorrow. All right, everybody. Hope that makes sense.